Hello everyone and welcome to another CheMEMEistry video. Today we're going to be looking at alkanes. Alkanes, they're like the mayonnaise of compounds.
Is mayonnaise an instrument?
They're boring, but we kind of need them, and also that means they're easy. So this will be a quick video, we'll just fire through some facts.
Simples.
Let's go. Alright, alkanes. So we already know they're basic, they're boring. They don't have any double bonds, they're all single bonds, and that means it's something called saturated. Lovely. It's also a hydrocarbon. What does a hydrocarbon mean? Contains only carbon and hydrogen. Again, it's boring, it doesn't have any functional groups.
You're basic.
Alright, it doesn't have an OH.
You're boring.
It doesn't have a double bonded oxygen. It doesn't have anything. It's just C and A. Now, let's think about the general formula then. Well, the formula is CN H2N plus 2. Well, that makes sense, but does it actually? Well, think about this. Each carbon is in a polyamorous relationship, alright? It's got two wives, and the wives are the hydrogens, okay? But the carbon on the end, it's got an extra side hoe, alright? If you think about it, it's only connected to one carbon, so it's got 3 bonds, it's got an extra side hoe. The carbon at the other end also has an extra side hoe. Well, we've got to add 2 more to the 2n plus 2. But sometimes this general formula doesn't work. Sometimes, if the ends are connected, we can get something called a cycloalkane. And a cycloalkane is just an alkane that's in a circle. And the cycloalkane has a general formula CnH2n. Why?
Why?
Well, because the side hoes have gone, alright, and they've joined up together. That's nice, isn't it? Now, what kind of isomers can alkanes produce? Well, not many. They don't have any functional groups, so no positional, no functional group isomerism, but they can have chain isomerism because the chain can get funky. They don't have a double bond, so they also can't do any stereoisomerism, so the only type they can do is chain.
You're boring.
They're unreactive, they're non-polar, and they're insoluble, so they don't really do much. They burn, but we'll be going over that in the next episode, the next video. I just can't focus. It's like the coffee has hit me, the isolation has hit me.
Child. Anyway, so...
But they do have some interesting boiling points. The general rule is as the chain length increases, the van der Waals forces get stronger and the boiling point increases.
I just need to add that chain branching actually decreases the boiling point. So the longer the chain will be the higher the boiling point, but if that chain branches, then actually it's a slightly lower boiling point than a chain with no branches.
Great. So where do we get them from? Well, crude oil is the answer. We separate it using a process called fractional distillation. That's pretty easy. We have a thing called a fractionating column. It's hottest at the bottom, coolest at the top, and we put the fractions in, and slowly they separate off as the column gets cooler. They condense, they get separated off, and they get sorted. Alkanes are boring.
You're basic.
I'm going to be honest. But in the next video, we'll be going over some reactions. So we'll do cracking, we're going to do combustion, and we're going to do free radical substitution, which are slightly more complex processes involving alkanes. It's pretty much the only interesting things they do. So I hope you enjoyed this brief rundown of alkanes. Add my socials. Please like, share and subscribe. Thank you for watching.